This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Alright, this is part 4 of Trig Functions for multiples of 30 degrees. So we're just going to do a few more examples. So let's do this one. Find the exact value of cosine of 120 degrees. So let's see. We have to find 120 degrees. Remember, this is 90. So 30 degrees more than that, so this is 120 degrees. So what we want to do is drop down, so we could think of this as a 30, 60, 90 triangle. You know, that doesn't look very perpendicular, but we have here a 60 degree angle right here, right? So this is the small side, that's 1, and then the long side, R, is 2, and this is square root of 3. Now let's put in the signs. This is really going to the left, so I'm going to write that as negative 1. Okay, so how do we get the cosine of 120 degrees? We're going to do the x over r, so it's negative 1/2. Now remember, instead, if you want, you could write that as an ordered pair up here. The ordered pair of that point up there is negative 1 square root of 3, and if you want, you could write, x is negative 1, y is square root of 3, and r is 2, and so what I did was to get the cosine negative 1 over 2. Alright, here's the next problem. Find the exact value of the cotangent of 17 pi over 6. First of all, where is 17 pi over 6? If you want, you could change that to degrees, but I know that 2 pi is one way around, and that's 12 pi over 6, so I'm going to subtract 12 pi over 6. And I know it's going to be coterminal with 5 pi over 6, right? So 17 pi over 6 is coterminal with 5 pi over 6. It doesn't equal that, but it still is going to have the same terminal side of the angle. So if you want to do 17 pi over 6, you would be going all the way around and then an extra 5 pi over 6. And that's a little bit smaller than pi, 5/6 of the way of pi, which is right here. So there's our angle. Okay, so you don't really have to show that whole angle. You could just do the 5 pi over 6, which is right here. Okay, so now let's just go ahead and drop down. So we could look at that 30, 60, 90 triangle. So what I have here, on the x-axis, I could see I'm going to the left. So remember, this is my unorthodox way of writing that side as just what the x value of the coordinate is, right? So I'm going to write negative square root of 3, even though the actual length of that side is square root of 3. This is up 1, and this has to be 2. All right, so we're always remembering that the small side is half of the long side, which is the radius. So in this example, x is negative square root of 3, y is 1, and r is 2. So if I want to get the cotangent of 17 pi over 6, all right, so now we have to remember what the cotangent is. It's x over y. Remember, the tangent is y over x? This is the reciprocal. So it's x over y, so it's negative square root of 3 over 1. So negative square root of 3 over 1 is just negative square root of 3. So I have negative square root of 3 for my answer. Now notice this is in quadrant 2, and remember that all students take calculus, so only the sine and its reciprocal function, the cosecant, is positive here. All right, so it makes sense that the tangent and cotangent will be negative. So it does seem reasonable, at least, that we've got the correct sign here. We've got the negative sign. All right, so you could do tons and tons of problems that have multiples of 30 or 60 degrees. They might be given in radians, might be given in degrees. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.